Welcome everyone to the course Climate Change in Extreme Events. Today is the summary lecture of week 8. In this particular lecture, we have already covered the topics related to predictive modeling of extreme events. We will go one by one whatever we have covered in this particular week 8, and then towards the end of this lecture we will talk about what is the assignment, and then next lecture we will talk about how to solve that assignment. So, this particular week was primarily centered around predictive modeling of extreme events. Why it is important? Because when we are talking about extreme events, we usually think about historical data trend, and once this is established using some sort of statistical model or machine learning model or simple model, then we try to project it for the future conditions to look at how these extreme events are likely to be changed under different scenarios, different places and different time periods, whether it is near future, mid future or far futures conditions like that. So, this is what basically we have talked about in this particular lecture, in this particular week. So, the first lecture we have talked about predictive climate extremes. How do we predict the climate extremes? Primarily, why it is important? Because we try to look at what is the early warning system for disasters. Then we try to look at what could be the mitigation and adaptation planning. Then we have to also look at the economic and infrastructural risk assessment. Then it is basically important to have understanding about what is likely to be happen in that particular scenario. Let us say what is the magnitude of flood in a certain region is likely to be occur, what would be the probabilities of occurrence of that particular event or above that particular event, so that we can design certain hydraulic structures or water resource structures there, so that we can mitigate those disasters. Or let us say if you are talking about urban flooding or extreme rainfall events, then we will also try to look at what would be the magnitude of different extreme events, what is their probability, and how we can develop some sort of early warning system to basically mitigate those negative consequences of these extreme events like that. So, primarily when we are talking about the predictive prediction of the climate extremes, we talk about heat waves, we talk about floods, we talk about droughts, we talk about hurricanes, we talk about fires like that. So, these are the events which are somehow directly or indirectly related to the hydrometeorological events and their changes in their properties, characteristics, and these different types of events occurs, and then therefore we are interested in to find out what is the behavior and what would be the behavior in the future conditions as well. So, then we talked about different types of predictive models. We have discussed about a statistical model, we have talked about machine learning models. In a statistical model, let us say we have talked about regression models, time series analysis. In regression models, we have talked about linear regression, logistic regression, Poisson regressions like that. In the time series analysis, we talked about ARIMA and SARIMA types of models, which can be used for time series predictions and all. Then in the machine learning segment, we have talked about supervised learning models, unsupervised learning and deep learnings, different types of models. For example, we have talked about in the supervised learning the random forest or support vector machine or neural networks. It is kind of a supervised learning. Or unsupervised learning, if we are interested in finding out the cluster or reducing the dimensionality of the data set like that, there we basically use some sort of unsupervised learning methods. Or in the deep learning since we are talk about various types of long short term memory or LSTMs types of models or CNN based models, which can be used for also for predictive model, and which can be also used for using the climate extremes prediction in the future time step or historical simulations as well. So, what are the source of the data set which is required to do these kind of analysis? One is we have talked about observational data, observational data can be originated from different types of government bodies, or some sort of semi government or private bodies or something like that. Those basically covers the data from the ground, and they provide that data at different locations, and then we use that data set for predictions of, or to analyzing the pattern or prediction of the extreme events, or in the future, or near future steps like that. So, that is called observational data set, which is basically coming from NOAA, IMD, NASA Earth observations data set. These data sets are primarily a graded based or point scale data set where we can use it. Sometimes this data set can be also in the form of remote sensing, where you can have information about the which is coming from the satellite data set itself, and that is can be also be used for different types of predictive modeling. For example, flood extent analysis, or let us say you talk about what is the extent of a particular wildfire in certain regions, like that. Then there is another type of data which is called reanalysis data. These are the data set which clubs together the observed data set plus model data set and merging it together to make some sort of reanalysis product, and that data set can be used for multiple different purposes. For example, there are several data set, ERA 5, NCEP, NCAR data set, or let us say Terra climate data set, or MERA or JERA 5. There are lots of reanalysis data sets are available, and this data set we can also use for multiple different extreme event analysis. We have in the previous tutorial we have also discussed about the how to download different reanalysis data set from the different sources and do the analysis. For example, from their on server, or let us say we have also talked about cloud based software, for example Google Earth Engine. There we can download the data set and we can do some sort of data analysis from these data sets as well. Then there is another data set which is called remote sensing purely, where we use these types of data set for remote sensing purposes, or let us say spatial data set, or for example we are trying to look at how the land and ocean are behaving under different circumstances, like that. For this we have different types of data set like MODIS, Sentinel, Landsat, and then these types of data set we club it together and to get the information about those locations where the observations are relatively difficult, or let us say we are interested in mapping the larger area of a particular region, so that we can have larger information or spatially distributed data set in a certain location, that basically we can use it using remote sensing data set. What is the pros and cons we have discussed about? For example, when you are talking about a statistical and machine learning model, the statistical models are, let us say, better performance with large data set, can capture non-linear relationship like that, but these models requires extensive computational resources, and interpretability issues are also with the machine learning of these models, because now we are these days we are primarily focusing on ML based or AI based models. So, these are the some of the limitations of these different modeling setup. Then in the next lecture we talked about how do we develop the model for different scenarios, or let us say for different climatic extremes conditions, because we know that we are going to use some sort of statistical model and this is our data set. So, now how we can use this data set in this statistical model or machine learning model to perform certain tasks. So, the first step is to data collection, whether the point data, observed data, ERA 5 data, reanalysis data, or let us say Landsat based data, remote sensing data set. We collect those data set, we pre-process it if there is any gap in the data, missing data, or is there any types of outlier, like that. We basically clean those data and organize those data, and then we basically look at feature selections. Let us say you have multiple input data set, then you select those input which is the best, can behave better, or can basically correlate with your predicted or prediction variable with highly correlated, and that basically we can take for feature selections, or let us say a process based understanding. Let us say there are certain processes which are directly correlated with certain types of data set or process. So, that is basically we take that data set and then basically we do some sort of analysis. Then there is a model training phase where basically we divide our data into certain parts. For example, we divide into data into two parts, let us say 80% is used for training and 20% is used for testing of the model. For 80% of data set, we only reveal model the 80% amount of this particular data set. This can be anywhere. It is not possible that we only take 80% data set from the beginning and till the 80%. It can be taken from randomly also from the different this data set, and the remaining 20% of the data set can be used for validation or test of the model. So, 80% based on that model we have revealed the data to model, and that basically we have trained the model. Training means we are setting up the parameter of the model and then we are trying to predict the observed data set with the input data set, and we correlate with our simulated and observed data, and then we fine tune our parameters in such a way that there would be little or lesser uncertainty between your observed data or observed variable y, let us say, and the simulated variable y dash. So, this is how basically we correlate and we try to find out the best possible combination of the parameters that can give us a minimum uncertainty or error or bias, and that is basically we can use it for further evaluation. Then remaining 20% of the data set is used. Let us say we have not exposed the remaining 20% of the data set to the model itself. How the model will perform to the unknown type of the data set. That is basically we use for performance evaluation, and that is basically we do, and then we try to look at what is R square correlation coefficient between simulated and observed data set. We look at RMSE error, we look at PBIAS error or metrics, or we use multiple MSE, like there are different matrices we use to evaluate the performance of the model, and based when we achieve a highest performance, that is basically we fix the model, and that is basically we say that okay, now our model is equally performing well for our known data set 80% and with our unknown data set, that is 20%. That is basically we call a perfect calibrated and validated model. Once it is done, then there are multiple different types of models we can also select and compare. Let us say within the statistical framework we can compare linear regression, logistic regression or ARIMA based model with each other, and then we can compare okay which one is giving better results, or for example in the linear regression we only use one variable with another variable if it is a single variable based. There is a multiple linear regression based also models available where we can use multiple inputs, and there is only one y, we can use it, and then basically that's multiple input data set we can predict the behavior of y. In the logistic model basically we look at what is the probability of binary outcome 0 or 1. Let us say whether the heat waves events are likely to occur, or what is the let us say occurrence is 1 and no occurrence is 0, like that we predict in the logistic regression models. Then there is if there is a nonlinear relationship, we use polynomial regression model for some sort of capturing the nonlinear relationships, like that. Or let us say we have a time series model, then we can use some sort of time series based model of ARIMA and SARIMA, like that, to forecast it for future time step. Or let us say we can use some sort of support vector machine or further ML based or AI based model for predicting the nonlinear pattern with with the input data set and that predictive variables, like that. What is the assumption and consideration? Data distribution we are assuming, and sometimes there is a problem with the multi-collinearity, which means there are multiple inputs, and that is possible that we have multiple inputs are also correlated with each other. So, in that case we can use some sort of dimension reduction algorithm which is called principal component analysis to reduce the dimension of the data set, and then we can use the 3 component of the principal component analysis PC1, PC2, PC3 which is not correlated with each other and can be used for model development, like that. So, this is basically So, this is basically we can use it for model development. So, then we have also talked about different types of machine learning model. For example, there are decision trees, there are random forest model, there are gradient boosting model, there are neural network model, like that. And then basically when we use these types of models, we also use some sort of optimization techniques. For example, hyperparameter tuning, where we try to look at different parameters which can be done by different types of algorithm, which is basically either the grid search method or random search method or Bayesian optimization method. We try to find out those particular parameters, and then once the parameter has been obtained, that is basically based on the 80% of data set, we try to fix those parameters, and then basically we fine tune the model with the rest of your 20% of validation data set for different model types, and then we compare, and then whatever the best model is, we select and then we use for climate extremes predictions. So, one is your called exploratory analysis, that is data attributes, data pre-processing, feature engineering. Then we build ML phase model, where we are training and testing of the data split. We are choosing the ML algorithm and then using the best possible or best model ML model with the training data set. Then we select multiple iterations through let us say when we have the validation data set as well, or when we are doing some sort of recursive predictions. So, then we repeat that step again and then iterate through step 3 and 9 again, and then basically we choose we choose the model testing data set, we compute the performances, and then we try to further fine tune the parameters using the hyperparameter tuning. Once it is done, if it is still there is a scope of we can improve the accuracy, we repeat this step again, and that basically we choose the model with the optimum performance. Sometimes what we also do, we use different types of models at once, and then we take the ensemble means of all the models, and that is basically we use it for our predictions. Why we do this? It is possible that maybe the one type of the model gives you very good results for very extreme events, very high magnitude events, or maybe it is possible that there is another type of models which are very good in low events or moderate events, like that. So, therefore, if we merging all together, we can also leverage that model which has good accuracy in the very extreme events computations, and then we can also take leverage from those models which has very good accuracy with simulating the moderate or low fluctuating or low time series magnitude models as well. So, this is basically how we can develop the ML model, and we can select that ML model for appropriate predictions of or estimation of the extreme events using the historical data set. So, there is another important aspect is validations. We have touched upon it. For example, we have testing phase, we have exposed the 20% of data set with some metrics, and then we try to find out the best possible or best performance of the model. There is another some of the very advanced techniques are also available. For example, we can use k-fold cross validation algorithm, where we divide our data set into, let us say, 5 or n spaces in equally part different parts. So, then we basically select one particular part as a validation, and rest of that is basically we can use it for training data set, and then we basically repeat this step a number of times. For example, here we are repeating that step for 4-fold. We can do that analysis for n-fold also. When we repeating that analysis, we have the better chance to validate our model for different part of the data set. It is possible that, let us say, you have collected the data from 1960s to 2024 or like that. In one period of time, let us say 1980 to 2000, we have very extreme events, high events, and but after 2000 we have not that much extreme events like that. So, when we are selecting different parts of the data set for validating the model, we are also exposing that model to that extreme events with other types of data set. So, in this way you have multiple model 1, model 2, model 3 and model 4, and then at the end we basically take the average of the model, and that is basically is the mean behavior of or ensemble mean behavior of all the models from this particular validation techniques. This basically gives you a better insight. Let's say we have a less number of data set, then these types of algorithms can give you a more better insight about the validation process. Or let us say if you have very few data set and we are using 20% data set, there is a very few numbers that might possible that when you are using that 4, 5, 10, 15 points of the data set, you won't be able to calculate the risk or that accuracy matrices accurately. So therefore, when we are using the validation steps like k-fold algorithms or k-fold cross validations, you have better scope for getting more number of data points for test, and therefore you would be able to calculate more better insight about the matrices of the or the comparison matrices of the models ensemble. Then we have talked about, let us say we have already know about model, we have already used the data set, and then we have developed the model, we have trained it the model with 80%, 20% or k-fold algorithms like that, and then our model has been fixed based on hyperparameter tuning, and then we have already know that okay, these are the parameters, and based on these parameters our historical model has been fixed now, and these are the input parameters. Now what we will do with that particular model? So basically we will use that model for scenario assessment. Let us say in the historical time period the rainfall was like this, and therefore this is your flood conditions, or rainfall was like this, that is your basically the drought conditions. But let us say you can tell to that model that if let us say we increase the rainfall by 10% or 20% or 30%, or let us say temperature by plus 2 degree or 4 degree or like that, what would happen with your climate extremes magnitude? What would happen the probability of occurrences of these climate extremes? Then we can understand okay, what is the scenario assessment, how we can develop different scenarios, and based on different scenarios we can try to look at what would be the magnitude, how the probabilities, how the the frequencies will change when we are changing these different types of magnitudes like that. Therefore, we use different types of scenario assessment. This is called RCP 2.6, that is low emission scenario, RCP 4.5, that is called intermediate scenario, 8.5 which is high emission scenario, or let us say we can also we use that CMIP 6 based shared socioeconomic pathways, which is SSP 1, 3, 4, 5 like that. So here basically we can include that socioeconomic development or the socioeconomic progress of whole world, and that we can take also into account, and then we try to look at develop that scenarios for different conditions. For example, what would happen if there is a sustainable path we are following? What is the middle of the road, sustainable with some sort of economical disbalance or social imbalance like that? Or what if we have some sort of regional rivalry or inequality, or let us say fossil fuel development economies which are we are continuing doing for let us say again for next 100 years like that. So in that different scenarios, what would happen to the temperature, what would happen to the rainfall, what would happen to the other meteorological parameters? Of course, those parameters will also change. When these parameters will change, how this change in the parameter will change the behavior of different climate extremes, how in the different parts of the world will behave flood conditions, what would be the conditions in the drought in different parts of the world, what is the situation of the heat waves. So that is why this is important. So we have already developed some sort of models, we will use these scenarios, and then we will try to project or predict the climate extremes based on different socioeconomic conditions or different scenarios assessment. So then we have also talked about let us say multiple different extremes. For example, extreme heat waves conditions in different scenarios. Let us say 2020 to 2052, that is mid century level assessment, and 2068 to 2100, that is basically in century assessment. And we try to look at these assessment for RCP 4.5 scenario and RCP 8.5 scenario, and then we can look at how that heat waves are changing across different scenarios. When you are talking about, let us say 4.5 and 8.5 scenario for the middle century, the heat wave frequencies are likely to be increased in this particular region. For the higher emission scenarios, the increase is likely higher compared to the lower emission scenarios like that. But when we are talking about the end century scenarios, here the heat waves are increase significantly compared to mid century scenarios. And when we are talking about very high emission scenario for end century scenario, here we have seen that there is a large area we have seen that is basically affected by a really highly increment of these heat waves across Europe. So, which means that based on the classification of different types of scenarios with the mid century level or end century level, we will be able to comment on how the extreme events are likely to be changed, their magnitude, their frequencies, their number of occurrences or inter-arrival period, or let us say spatial clusters where we have a significant increment or significant decrement of different types of extreme events in the future scenarios or future conditions for different place of the world like that. So, that is basically we can use it for these different models as well. Then there is another case study we have discussed. This is, let us say, Indian subcontinent. We can talk about the precipitation changes across different scenarios. For example, you can see that precipitation changes are very significant in RCP 585, which means there is a higher likelihood of high intensity, high magnitude rainfall, and that will basically produce more catastrophic floods in the future conditions, because rainfall is a direct very plays a direct role in flood generation processes like that. Then there is another case here when we are talking about maximum temperature, and we can see that as we are increasing the scenarios, it is basically tells that the maximum temperature are also likely to be increased in the future conditions. So, when we are dealing with different types of scenarios, if this is fossil fuel dominated societies, we are still continuing using that fossil fuels, it is highly likely that we will emit a lot of carbon dioxide gas or GHG emissions to the atmosphere, and that will lead to more warming, more extreme weather conditions, and therefore that will lead to more climatic extreme condition across India, across world like that. And then we have also talked about, let us say, minimum temperature conditions. Here also we can see that there is a significant places when we are talking about in the higher emission scenarios, the minimum temperature are also likely to be increased, which is less winter time or not very low temperature winter in the future conditions like that. So, the results of this analysis suggest that there is an increased probability of extreme flooding in coastal areas or different parts of the Indian subcontinent. There is a more frequent and prolonged drought events in the arid region, and therefore that would lead to some sort of more water scarcity situations in the future time steps like that. So, we have started with different types of the models. We compared the models, their pros and cons, different types of the models, how do we select those different models based on what factor. Then we have talked about how we can set up the model, what is the pre-processing step, what is the hyper tuning step, how do we find out the parameter estimations, and then we talked about what is the calibration phase, what is the validation phase, how we can use different types of advanced algorithm, which is, let us say, LOCCV or or let us say k-fold validation algorithms like that. And then using all of these steps, when we come up with a very best model and we have defined that model, how we can use that model for different scenario analysis. Let us say we can divide our data set into multiple parts, or future condition data set into multiple scenarios, and then we can divide our data set into, let us say, mid century scenario, end century scenario, or near future scenario. And then we can look at it, let us say, how we can use that information to predict or project, different types of climate extremes in the future conditions like that. So, this is whole concept we have covered in this particular week 8. Now, based on whatever we have discussed in this particular week, we can test about and look at some sort of time series analysis concept. We can read about what is the stationary and non-stationary part, and we can also think about making simple moving average based, let us say, forecasting model to understand how that forecasting works. Of course, this is not a very robust model, but this will give you a very first hint that how a particular model can be used for different forecasting using the time series data set. So, you can try this assignment, and the next lecture we will discuss about the solution of this assignment. For this lecture, this is the total content. Thank you so much for your listening.